Welcome back. This is video 4 of the Stanford Microfluidics Lab ITP Tutorial series. This video discusses the operation of the microscope, camera, and camera software. Before we begin, we encourage you to check out the Microscopy U tutorials linked in the supplementary document. Let's talk about the microscope setup. Here is what our Nikon TE300E inverted microscope in room 211 looks like. You'll notice there are a couple of major components, including the stage, XY knob, Z knob, camera, filter cube selector, objective turret, and LED. In this demo, we will use a 10x 0.4 objective, a 0.5x demagnification lens, and a blue-green filter cube. In this setup, we are using Thor Labs high-power LEDs. To set up the LED, attach the Nikon adapter to the front of the LED, and then attach the LED to the back of the microscope. Connect the LED cable to the LED driver. Then, turn on the driver and set to brightness mode with full power. We here also use an Orca Flash 4.0 V3S CMOS camera. To set up the camera, first mount the demagnification lens. Then use the set screw on the microscope side port to fix the camera in place. Turn on the camera using the on-off switch at the back of the camera head. The PC should provide a noise indicating it has detected the camera. Remember to set the microscope optics to output the image to the camera side port. After we have set up the chip, filter cubes, LED, and camera, we must find the channels using the microscope. We recommend to use the software to do this more easily. Open HC Image Live. You should see a camera listed with a name like this. Press Live. You may see an image like this. This means the viewfinder is too zoomed in. Zoom out by hovering the mouse above the live image and scrolling down. You should see vignetting at the corners of the images as shown here. Choose an exposure time of 10 milliseconds. Now let's find the chip. Keep the room lights on during this procedure. Turn the microscope Z knob until the objective is as far as possible from the chip. Now, align the LED illumination coming from the objective over the chip by physically examining the microscope stage. Try to align the light emanating from the objective with the channel on the chip. Finally, turn the Z knob so that the objective slowly approaches the chip. Alternate between watching the HC image output and physically looking at the stage to avoid crashing the objective into the chip. You should eventually observe a channel come into focus. If you cannot focus onto any channel, try moving the stage in X or Y slightly and repeat the last two steps. If you perform an ITP experiment on an NS12A chip, you should observe, after turning off the room lights, a peak quickly forms downstream of the channel intersection. We're done. Proceed to video 5.